Students, our next topic is electromotive force or EMF. We know that when charges flow through a conductor, then electric current flows through the conductor. These charges in a conductor, they cannot start flowing in a direction at its own. किसी कंडक्टर के अंदर जो करंट कैरियर हैं या इलेक्ट्रिक चार्जेस हैं वो अपने आप फ्लो नहीं करते। इलेक्ट्रिक चार्जेस या करंट कैरियर्स वे फ्लो कर सकते हैं अगर हम उनके ऊपर कोई एक्सटर्नल फोर्स लगाएं जो उनको कंपेल करे एक डायरेक्शन में मूव करने के लिए। तो दिस एक्सटर्नल फोर्स विच कंपेल्स द करंट कैरियर्स टू मूव इन ए डेफिनेट डायरेक्शन, दैट इज कॉल्ड इलेक्ट्रोमोटिव फोर्स. Electromotive force, this is supplied by a cell or battery. Electromotive force कोई सेल या बैटरी या जनरेटर ही सप्लाई करता है. Therefore, now we study EMF. Electric current is possible in a closed circuit if there is a source of external force or if there is a source of energy which compels the current carriers to move in a definite direction from lower potential energy to higher potential energy. This external force which makes or which compels the current carriers to move in a definite direction is called electromotive force or EMF. Electromotive force is associated with a arrangement or mechanism which can supply energy or which can do work to move the electric charges from lower potential energy to higher potential energy. Such an arrangement is called source of EMF. The source of EMF may be a cell or a battery or a generator. Now we define EMF of a cell. EMF of a cell is defined as the maximum potential difference between two electrodes of the cell when no current is drawn from the cell. The maximum potential difference between the two electrodes of the cell when no current is drawn from the cell is called EMF. Now EMF can also be defined as the energy supplied by the cell to drive unit positive charge once around the complete circuit. It is defined as the unit positive charge. It is defined as the amount of work done, or it is defined as the amount of energy supplied by the cell to drive unit positive charge once around the complete circuit. And this is given by E dot dl integration over a closed path. Here E is the electric field or electric field intensity, that is the force expressed by unit charge, and dl is the small path segment vector. We know that E dot dl, this is the amount of work done in moving a unit positive charge over a small distance dl. Now integration over the closed path, this denotes the total amount of work done in moving unit positive charge once around the complete circuit. Therefore this work done or this energy supplied by the cell is equal to EMF of the cell. Now a cell is represented by two parallel lines separated by a small distance. The larger line represents the positive electrode, smaller line represents the negative electrode. SI unit of EMF of a cell is volt or joule per coulomb. EMF of a cell is said to be 1 volt if 1 joule energy is supplied by the cell to drive 1 coulomb of charge once around the complete circuit including the cell. EMF of a cell depends upon nature of electrodes, nature and concentration of electrolyte, and temperature of cell.